Hi everyone. So in this video, we're going to be looking at how to solve the LeetCode question number 1930. So it is titled Unique Length 3 Palindromic Subsequences. And essentially what the question is asking is that we need to find the unique number of palindromes which has a length 3 and it's a subsequence of this given string s. Now, as we're aware, a palindrome is something that reads the same forwards and backwards. And here, how they have defined subsequence is that it's a string in which the order of the characters do not change, but you're allowed to delete any characters in between it. So let's say here they've given an example. If it's A, B, C, D, E, then you can say that if you delete B and D, then ACE is a valid subsequence. And in our case right now, this is not a palindrome, but this is just an example of what a subsequence is. So here we need to return the number of valid palindromic subsequences of length 3. So let's say for in case of this string AABCA, now here as they have given, we can form three palindromic subsequences of length 3, namely being ABA, which we can get from A, B, and A. So we can remove the in between A and C. We can get all A's, so A, and the last A, as well as A and CA. So all of these are valid palindromes, so the output will be 3, and so on. So in order to approach this particular problem, the obvious approach would be is a brute force approach where you try to get all of the permutations and combinations. So you basically get all of the three length strings, substrings, or subsequences, and you check if each of them is a palindrome or not. So that was basically my first approach. So I'll be showing you the code here. The first submission here that I did is a brute approach one, and here all I'm doing is I'm running three loops I, j, and k, which are going to essentially check for every subsequence of length 3. So that is what I'm doing. So sub is equal to s of I, j, k, so the values at I, j, and k pointers, and I'm doing a check to see if it's a palindrome. And if it's a palindrome, I'm also doing a check to see if we have already checked or if we have already gotten that palindrome, since we need only the unique palindromes. And if it's a unique one, then we increment our answer variable and return it. Now, as you can see here, the time limit has been exceeded in test case number 24. Since this is not an optimized approach, we have three loops that are running, so this will be of time complexity O of n cube, and hence not a best approach. Now I'll be explaining my second approach that I did, which got accepted, and I'll explain first my thought process for this, and then we'll go over the code. So essentially, what the algorithm that I came up with is that uh, let's take the string itself, AABCA. Now, for a three uh, length palindrome, the first and the last characters have to be the same, right? So if it begins with A, it has to end with an A for a palindrome. And so the only value that's going to change is going to be the middle character. So my approach here is essentially that if let's say we take the first character as A, and so I'm going to keep one pointer. So let's take my left pointer at A, and I take my right pointer at n minus 1, which will be the last element. Essentially, I'm going to search for my right pointer until my right pointer's value is the same as my left pointer, so that I can check for a valid palindrome. Once I get that value, so here in my first try itself, my left pointer will be at 0th position and my right pointer will be at n minus 1 position. Now, to form a three subsequence length palindrome, we can take all of the unique values in between these two pointers. So, in between the two A's, we have A, B, and C. All of them are unique characters, and each of them could be a possible middle value, right? So, you can have A, and A, B, and A, C, and A. So, in this way, we just need to add to our answer the number of unique values between the left pointer and the right pointer. And that's all we need to do. We just need to keep doing it for each unique element. So now that we have checked A, we can increment our left pointer to the next index 1. But here we have already checked A, so we can go over it. Now we have B, so now we can again like check if there's a B here. There's not a B. So in this manner we can keep moving the left pointer and the right pointer and just check the elements in between. So that is basically the approach I've used here. In my code, I'm getting the length of the string. I've declared a variable for answer. My left pointer is initialized to 0. I'm maintaining a set called checked characters, which basically just has all of the characters that we've already checked with our left pointer, so that we don't keep checking the same characters again and again. So I'm running a loop while left pointer is less than n, and each in the loop you can see my left pointer is constantly will get incremented by 1 every time. So I'm going to first take the character that I have at my left pointer, and I'm going to first check if it's not in the checked characters, because if it's already checked, we just increment and we go to the next one. And so now if it goes inside because it is not checked, then we initialize a right pointer to the last value. And I'm in my loop here. Now I'm going to open up a loop to basically check if the value at my right pointer is not equal to the value at my left pointer, and my left should be less than right. In this case, I will decrement my right pointer until I get a valid uh, until the value at my left is equal to my right. So it's a very simple code. I'm just going to check if the value at my right should be at the value at my left. Once I get that value, I'm just doing a simple check to see that my right minus left plus 1, essentially my index, higher index minus the lower index plus 1, should be greater than or equal to 3, because we need a minimum 3 length subsequence. And if the value at the right is equal to the value at the left, if it is, I'm simply appending with my answer. What I'm doing is I'm taking the string from the left index plus 1, because we just need the in between values up till the right minus 1. So since the right is not included in this range, we take all of that. I'm converting it to a set to get the unique characters in it alone, and we're just appending the length of that. And finally we'll be able to return the answer. And so that's how this code is solved. And it's a pretty good code. I would say it's a very intuitive code, because you can easily just understand the logic behind it, and it's easy to implement once you understand the logic. So that's it for this video, and I'll see you again in the next one. Bye bye.